Okay, so we're going to be looking at some mechanics here, and we're asked to find an expression for the velocity and acceleration given that the displacement is given by, and then we've got a series of functions. Now we know to get the velocity and the acceleration, we have to differentiate. So if I differentiate, so if I take d over dx from s, I get velocity, so velocity is the rate of change of the displacement. And if I then take d over dx, I get acceleration. So acceleration is the rate of change of that velocity. So all I have to do is differentiate these functions. So if I have s equals 4t to the power 4 minus 1 over t, I've got to firstly change that into a form where I can differentiate more easily. So that's 4t, 4 minus t to the minus 1. So then I've got to times it and take one off for each one of these. So I'm going to times my coefficient, which is 4, by the power here, which ironically is also 4. So that's going to be 4 times 4 is 16, t to the power, and then I'm going to take one away from that exponent. So 4 minus 1 becomes 3. Now I'm going to multiply the coefficient and the exponent. So that's minus 1 times minus 1, which is plus 1. T to the power of minus 1 is minus 2. Then we can get acceleration again. We can keep going. So 16 times 3. That might just be a job for the calculator. So 16 times 3 is 48. 48. T 3 minus 1 is 2. And then that's going to be 1 times minus 2. So that's going to be minus 2t to the minus 3. Okay, and maybe I'll pick one more of these to do. So let's go ahead with C. So what I'm going to do is firstly expand these brackets so that I can get it into a form where I can differentiate more easily. So 3t squared minus 1, 2t plus 5. I'm going to do my parrot-beak method. So this multiplies this, this multiplies this, this multiplies this, this multiplies this. I'm following the lines on the parrot-beak and I'm multiplying everything that touches. So initially I've got 3t squared times 2t. It's going to be 6t cubed. This is s equals. That second line, that's 3t squared times 5, so that's plus 15t squared. Minus 2t, following this line here, and then I've got minus 5. Okay, so all I have to do now is follow the rules of differentiation. So I'm going to times the coefficient and the exponent, that becomes 18t squared. 15 times 2 is 30, plus 30t, and then 2 times, there's a little hidden 1 here, so 2 times 1 is just 2, 2, and then t to the power of 0 is just 1. There's a hidden exponent of t to the power of 0 here, so this term just gets deleted away. And then we'll keep going. So acceleration equals 18 times 2 is 36t plus 30. Okay, and we'll just have a quick look at this last one. So we have a particle is moving in a straight line. At time t seconds, its displacement x from a fixed point on the line O is given by x equals 2t cubed minus 8t. Find the velocity when t equals 3. So we can find the velocity by recognising that it is going to be the differential d over dx of our displacement. So that velocity is going to be 2 times 3 is 6t squared minus 8. So the velocity evaluated at t equals 3 is going to be 6 times 3 squared minus 8. So 6 times 9 is 54. So that's 54 minus 8, which is going to be 46. Okay, the acceleration of the particle when t equals 2. So I'm going to differentiate this again. I'm going to have that's 12t. And then I'm going to evaluate my acceleration at t equals 2. So it's going to be 12 times 2, which is going to be 24. Oh, I should say this is meters per second. And this is meters per second. Meters per second squared acceleration. Hope that helps.